Good day, class. I am your teacher for today. My name is Sir Reden from PUP Santa Maria. The discussion for today is identifying the relation between changing quantities. The learning objectives are identify the relation of two quantities and use equation to represent relation between two variables. Hopefully, before the end of discussion, we are able to reach our objectives. Exploring math. Consider the given problem. Two buddies, Chris and John, decided to drive their motorcycle one fine day. They drove for the same amount of time. Number 1. Chris drove faster than John, who ran more miles. Number 2. John slower than Chris, who ran fewer miles. Quantities can be related in two ways, directly and inversely. As the speed decreases, the distance decreases. Therefore, speed and distance are directly related. As this speed decreases, the time increases. Therefore, speed and time are inversely related. Example: name the two quantities in each situation. Tell whether they are directly and inversely related. Explain the relation. Example number 1. The number of miles driven related to gas left in the tank. Number 2. The side of the square is related to each area. Number 3. The time a teacher spent grading paper is related to her number of students. Solution. Quantity 1. Miles driven. Quantity 2. Remaining gas. Relation inversely. Explanation. As the miles driven increases, the amount of gas decreases. Number 2. Quantity 1. Side. Quantity 2. Area. Relation directly. Explanation. As the side increases, the area increases. Number 3. Quantity 1. Time. Quantity 2. Number of student. Relation directly. Explanation. As the number of students increases, the time spent increase. In some situation, relation between quantities can be expressed by other form. Quantities can be represented by a variable, and the relation can be expressed by an equation. For example, in each square, the perimeter y and the length of each side x are two variables. The relation can be expressed by the equation y is equal to 4x. Example number 1. Write an equation to represent the relation between x and y in the following table. X is equal to 1, 2, 3, 4, 5, 6. Y is equal to 3, 5, 7, 9, 11, 13. Solution. Rewrite the value of y in the terms of the value of x. X is equal to 1, 2, 3, 4, 5, 6. Y is equal to 1 plus 2 times 1, 1 plus 2 times 2, 1 plus 2 times 3, 1 plus 2 times 4, 1 plus 2 times 5, 1 plus 2 times 6. Based on the table, you can conclude that the relationship between x and y can be represented by equation y is equal to 1 plus 2x. Example number 2. Write an equation expressing relation between a and b in the given table. A is equal to 2, 4, 6, 8, 10, 12, 14. B is 5, 11, 17, 23, 29, 35, and 41. Solution. Rewrite the value of b in the terms of the value of a. A is equal to 2, 4, 6, 8, 10, 12. B is 3 times 2 minus 1, 3 times 4 minus 1, 3 times 6 minus 1, 3 times 8 minus 1, 3 times 10 minus 1, 3 times 12 minus 1, 3 times 14 minus 1. Based on the table, you can conclude that the relationship between a and b can be represented by the equation b is equal to 3a minus 1. And that's all for today. Thank you for listening, class.
Hello class!
Hello guys, our topic is all about direct variation. And our objective is, in this lesson, you are expected to, first, to write equation representing direct variation. Second, solve problem solving direct variation. Exploring math. When a bicycle is being pedaled in a certain gear, it travels 600 m or miles for every 3 pedals revolutions. How many revolutions would be needed to travel 600 miles? Let x be the number of pedal revolutions. The distance traveled varies directly as the number of pedal revolutions. Two ordered pairs determined by the variation are 3, 16, and x and 600. Thus you have 16 over 3 is equals to 600 over x. 16 is equals to 1800 and x be 112.5. It would take 112.5 revolutions to go 600 miles. Mathematical relationship between two variables expressed in the equation in which one of the variables is to the constant multiple of the other equation is direct variation. The relationship between the two variables remains in the constant ratio. It's called direct variation. If there is an increase in two related variables, it is called the direct variation. It represents the change of a variable with respect to others of others. The graph below shows direct variation between y and x. This is the four example of direct variation. Total cost of egg 5, 3, 6, 9, 12, 15. The number of eggs bought x 1, 2, 3, 4, 5. Y over x is equal to 3, 3, 3, 3, 3. The table shows the relation between the total cost of eggs and the number of eggs bought. As the number of eggs increases, the total cost also increases. The ratio of y to x is equal to constant 3. Such a relation is called direct variation. Direct variation: the statement y varies directly as x or y is directly proportional to x mean that k is equals to x for some constant k. The number k is called the constant of proportionality. In the given table, 2 is the constant of variation and y is equals to 2x is the equation of variation. Example 1. Given that m varies directly as n and that m is equals to 42, when n is equals to 2, find the following. The constant of variation, the value of m when n is equals to 3. Solution. Since it is the given that m varies directly as n, then definition of direct variation, m is equals to kn. M is equals to Kn. To solve for constant of variation, substitute M is equals to 42 and N is equals to 2 to the given equation. M is equals to Kn, 4 is equals to K times 2, K is equals to 21. B. To solve for M when N substitute K is equals to 21 and N is equals to 3 to the given equation. M is equals to Kn, M times 21 times 3 is equals to m 63. Example 2. Celine is traveling by car and the distance she travels d varies directly with the amount of time t that she drives. In 3 hours, she drove 120 miles. Find the constant of variation and the equation relating d to t. Solution: because d varies directly as t, we must have constant k such that d is equals to kd. d is equals to 120 when t is equals to 3. Substitute. In the given equation, 120 is equals to 3 is equals to k times 3. 40 is equals to k, therefore the constant of variation is 40 mph and d is equals to 40t. Let's try solution. R is equals to 12,600 when A is equals to 420. Substitute to the given equation to find K. 12,600 is equals to K divide 420. K is equals to 30. R is equals to 30 times 900. R is equals to 27,000. Okay, that's all. Thank you for listening. Don't forget to like and subscribe our YouTube channel. Bye-bye!
Hello everyone, I'm Rochelle Daragay and welcome to my YouTube channel. A pleasant day everyone. I'm Rochelle Daragay, your teacher in Mathematics 9. So today, I will discuss the direct squared variation. Direct square variation. The objectives. In this lesson, you are expected to solve problems involving direct square variation. The area of a square varies directly as the square of its sides. Study the following table. Length of the side x and area of x squared. 5 cm, 25 cm, 1.5 cm, 2.25 cm, 3/2 units, 9/4 square units, 25.5 meter, and 650.25 meter squared. If x and y have a direct square relationship, it means that the term x is proportional to a constant multiplied by the y squared. In such case, the nonlinear relation between the two quantities can be expressed by an equation y is equal to kx squared, where y varies directly as the square of x and the constant of variation is k. This relation is called direct square variation. A direct square proportion graph is used in mathematical equations. A graph is a pictorial representation of ordered pairs of numbers from which of the readers may quickly determine relationships between quantities. A change in one quantity may cause another quantity to change. We say one quantity is a function of the other. So for example, the area of a circle is a function of the radius. That is, the area depends on the size of the radius, and the area of the circle increases accordingly. In this example, the radius is called the independent variable, and the area is the dependent variable. A graph is plotted as a picture of ordered pairs of numbers. To draw a graph, we use graph paper and a set of ordered pairs of numbers. So let's have another example. Assume that y varies directly as the square of x when x is equal to 10, y is equal to 80. Find the value of x when y is equal to 80. Since y varies directly as the square of x, then the equation of variation is y is equal to k x squared. To solve for the constant of variation k, substitute k is equal to 10 and y is equal to 80. So the formula that we need to use in this equation is y is equal to k x squared. So y is equal to kx squared. The value of y is 80, so 80 is equal to k. The value of x is 10, k times 10 is squared. So k is equal to 80 all over 100. 80 divided by 100 is 4 all over 5. So the answer for k is 4 all over 5. To solve for x, when y is equal to 80, substitute k is equal to 4 over 5. So in y is equal to kx squared, the value of y is 80 is equal to the value of k, which is 4 all over 5 times x squared. So x squared is equal to 80 times 5 all over 4, the reciprocal of 4 over 5, is equal to 100. So x squared is equal to 100. It will become square root to cancel out. So the answer is positive negative 10 for the value of x. Okay class, did you understand our examples? So if yes, let's try this equation. In this equation, you have 10 minutes to answer. Find the equation of variation in which y varies as the square of x when x is equal to 6 and y is equal to 3. Find the value of x when y is equal to 3. In this equation, it is most likely our first example. Okay? So, let's check your work. May I call on Casey to share the answer for k and x? Okay, the answer for k is 3 all over 50 and x is equal to positive negative 10. Okay, that's correct. Thank you for your participation. So, okay class, that's all for my part of my discussion, the direct square variation. I hope you learn a lot. So, thank you and God bless you all.
Tutorial vlog. Renzo Tutorial Vlog.
So good day everyone, I will be discussing the inverse variation. So welcome students. So this is our desired learning outcomes. So in this lesson, you are expected to write equation representing inverse variations. 2. To solve problems involving inverse variation. Next. So first, let's have an exploring math. Dr. Tan organized an outing for her class and it costs 6,000 pesos to hire a bus that can care for the students. So the table below shows 6,000 pesos will be divided based on the number of students who will ride the bus. So the number of students which represent X is 1, 2, 3, 4, 5, 6, and so on and so forth. While the amount shared by each student, which represents Y, is 6,000, 3,000, 2,000, 1,500, 1,200, and so on and so forth. Well, when we multiply the X and Y, we get the answer 6,000 constantly. I have a question, class. What is the above table shows?
The relation between the number of students and the amount shared by each student.
Very good. Another one. What could you observe, class?
As I observe, ma'am, as the number of students increases, the amount shared decreases.
Very good observation. Lastly, what would you see on the X and Y?
The product of x and y is always equal to a constant 6,000.
Very good. All of your observations correct. And such relations are called the inverse variations. So what is the inverse variation? The statement y varies inversely as x or y is inversely proportional to x means that y is equal to k of x, k over x rather, for some constant k. So the number k is called the constant of variation or the constant of proportionality. So let's have an example. So the table below shows some values of x and the corresponding values. It is given that y varies inversely as x. So the solution will be, since y varies inversely as x, then y is equals to k over x. To solve for the constant variation, k get the product of x then y, x 10, 20, 25, 50, while y is 30, 15, 12, 6. Can anyone solve the product of x and y?
Me, ma'am.
Okay, student number 1. What is the answer?
300, ma'am.
How would you know that it is 300?
I multiply the x and y to get the constant variation, which is 300, ma'am.
Very good. So let's have the next table show that the answer is 300.
Since the variation constant is 300, the equation of variation is y equals 300 over x.
Okay, very good. So since the variation constant is 300 and the equation of variation is y is equals to 300 over x. Let's proceed to the next slide. And this graph shows the illustration of y is equals to 300 over x. Okay, understand class?
Yes, ma'am.
Okay, let's proceed to the example number 2. Suppose m is inversely proportional to n, and when n is equals to 5 while m is equals to 1/2, find m when b is equals to 12. The solution will be, because m is inversely proportional to n, then m is equal to k over n. To find the constant variation, k substitute m is equals to 1/2 and n is equals to 5. Who wants to substitute it?
Me, ma'am.
Okay, student number 2.
M equals to K over N. 1/2 equals to K over 5. K equals to 5 over 2.
Very good. So therefore, the constant variation is 5 over 2. So, another one.
I'll try. Ma'am, M equals 5 over 2 over N.
Okay, very good. So, who wants to substitute it? Yes, student number 3.
K equals 5 over 2.
Okay, very good. So, let's solve it together. So, m is equals to 5 over 2 over n. And m is equals to 5 over 2 over 12. When we multiply it, 5 over 2 multiplied by 1 over 12. So, what is the answer? Student number 4.
5 over 24, ma'am.
Very good. So therefore, the answer is 5 over 24. So let's try. The number of pens sold, which represent n, varies inversely as the price per pen, which represent p. And if 4,000 pens are sold, the price of 15 pesos each, find the number of pens that will be sold at the price of 12 pesos each. So the solution will be, since n varies inversely as p, then the equation of variation is n equals to k over p. Anyone who wants to solve the equation? Okay, student 5.
To find the constant of variation, k, substitute n equals 4,000 and p equals 15. N equals to k over p. 4,000 equals to k over p. Thank equals to 4,000 multiplied by 15. K equals to 60,000.
Okay, very good. You are correct. So another one. Who wants to substitute the given equation? Yes, student number 6.
To find n when p equals 12, substitute the value of k to the given equation. N equals 60,000 over 12, n equals 5 over 0. Therefore, 5,000 pens will be sold at 12 pesos each.
So therefore, 5,000 pens will be sold at 12 pesos each. Okay, very good. So thank you for participating, class. And Ms. De Guzman will discuss the next topic. Thank you.
Don't forget to like, share, subscribe, and hit the notification bell for more upcoming tutorial videos. Follow me on my social media accounts. Thanks for watching. Bye.
Hello everyone, this is Teacher Leyan. For today, you will learn about joint and combined variation. Before we start, here are your learning goals. First, Students are able to write an equation representing joint or combined variation. Second, students are able to solve problems involving joint or combined variation. Now, let's proceed to our topic.
Exploring math.
When you say z is jointly proportional to a set of variables, it means that z is directly proportional to each variable taken one at a time. If z varies jointly with respect to x and y, the equation will be the form of z is equals to kxy, where k is the constant. Equation: c is equals to 5ab. Variable c is jointly proportional to a and b. That means c directly proportional to both a and b. Table ABC. A is 1, 2, 1, 4, while B is 1, 1, 2, 2, while C is 5, 10, 10, and 20. In this table, doubling A causes C to double. Doubling B causes C to double. Doubling both A and B causes C to quadruple. Consider the surface area of a cylinder with a base radius stands for r centimeter and height stands for h centimeter. The formula to calculate its surface area is S is equals to 2 pi RH. From the formula, you will find out that 2 is constant value. If h is fixed, then S varies directly as r. If r is fixed, then S varies directly as h. If neither r nor h is fixed, then S varies directly as RH. Such a relation between S, R, and H is called joint variation. We say that S varies jointly as R and H. Joint variation. The statement Y varies jointly as X and Z, or Y is jointly proportional to X and Z, means that Y is equals to kxz for some constant k. The k is called the constant of variation or the constant of proportionality. I have here some example. Example 1. Suppose y varies jointly with x and z and y is equals to 12 when z is equals to 2. Find y when x is equals to 10 and z is equals to negative 3. The solution is, since y varies jointly with x and z, then y is equals to kxz. To find the constant of variation k, substitute y is equals to 12, x is equals to 12, and z is equals to 2. Y is equals to kxz. The y is 12 is equals to k times 5 times 2. 12 is equals to 10k and k is equals to 12 over 10 or 6 over 5. Now, you know the value of k. You can rewrite the equation as y is equals to 6 over 5 xz. To find y, when x is equals to 10 and z is equals to negative 3, substitute in the given equation y is equals to 6 over 5 times 10 times negative 3. And the value of y is equals to negative 36. Another example, the labor cost stands for C for installing ceramic tile varies jointly with the length stands for L and width stands for W of the room in which it is installed. If the labor cost for 9 foot by 12 room is 3,240 pesos, then what is the labor cost for a 6 foot by a foot room? The solution is, since the labor cost varies jointly with the length and width, then C is equals to KLW. To solve for the constant of variation K, substitute C is equals to 3,240 and length is 12, W is 9 to the given equation. C is equals to KLW. 3,240 is equals to K times 12 times 9. K is equals to 3,240 over 12 times 9. And the answer is K is equals to 30. It follows the equation of variation is C is equals to 30 length and width. To solve for C, substitute length is equals to 8 and width is equals to 6 to the equation of variation. C is equals to 30 length and width. C is equals to 30 times 8 times 6. And the answer is C is equals to 1,440. Therefore, the labor cost for 6 foot by 8 foot room is 1,440 pesos. Thank you for listening.